So greetings, greetings YouTube. Beautiful mind here. Let me see. Our Professor Pfeiffer. Let me see. No major announcements. The main thing with our class is that mainly just be sure that you're completing the assignments that are on Blackboard, that you have full access to homework, and you're getting those assignments completed. We can be on a. You can anticipate exam one to open up next Wednesday. So not this Wednesday, but a week from this Wednesday. Other than that, if there aren't specific questions, I'm just going to kind of keep making my way through the homework assignments. If you want to see like a lecture presentation of any section, it's already on my YouTube channel for the entire semester. Let me know and I can show you how to find it. I do monitor the chat and feel free to unmute yourself if you have questions. Otherwise, I'm just going to hop into the assignments. So let me see. I can get rid of this. It's going to be here. Transition. Okay. Oh, that's weird. Okay. Yeah, let's hop into it. Okay. All right. And so, yeah, once you get into my Zoom call, again, this is an asynchronous setup. So to get your attendance, preferably you want to get your attendance as soon as I start class. Once you get your attendance, if you can't stay, it's fine. You don't have to stay. But I think I probably will start to do that whole, okay, I take attendance right at the start of class, and then if you come in between the start of class and the first 15 minutes, then that's considered late. And then after 15 minutes, I'll let you in, but I'm gonna stop taking attendance at the 15-minute mark. So I'll try to keep announcing that each day. Hopefully everybody hears it, but more than likely after the first 15 minutes of class, I'm gonna stop taking attendance. All right. So if you want your credit, the best thing is just to kind of be there early. I usually try to get in a little bit early and be waiting. That's usually what I'm doing as best as I can. But if you want attendance credit, that 10 minutes leading up to class, you just want to be waiting. Get your attendance right at the start of class, and then after I do that first wave, from the start of class until 15 minutes, that's considered late. Let me see. We got somebody else coming in, and then after 15 minutes, I'll probably stop taking attendance. I'm gonna mark everybody as absent from that point on. Okay, so that's just a little heads up. Okay, I haven't started doing that yet, but I do need people to kind of just check in. That's all. Okay. So we're moving into week 3. So for exam one, which will open up next Wednesday and it'll be due next Sunday. All right. So you'll have Wednesday, Thursday, Friday, Saturday, Sunday. I think like 5 days to kind of work on exam one for full credit. You can actually work on it past the due date, but it's going to be a 10% late penalty for any questions submitted past the due date. So that's kind of how that goes. So this week we'll just focus on section 1.3 functions, right? We kind of have a leisure pace. We don't have to rush. We'll take our time through these assignments. If at any moment, we can actually go back to any question from the past as well, because I know that everybody's kind of on their own rhythm. So if you ever want to go back, just let me know, and we can. And if you want some background information on these notions that I'm speaking on, I'd have to refer you to my pre-recorded lecture on this section. Okay. So this question comes from section 1.3 on functions. Let me see if I can give a little background or a little disclaimer on functions. So the simplest way I can think to articulate what a function is basically you have the set of input values, it passes through a function, and then you have a set of output values. So the functions it's basically going to take your inputs and generate a set of outputs that correspond to each input. That's what a function is, right? So in this context, this is called a correspondence diagram. On the left, we have our set of inputs. So this 19, 17, and 10, that's like our x values, our set of inputs, right? And then on the right are going to be outputs. In this form of the correspondence diagram, notice it's not really associated with any specific function. It just means take these set of inputs, and then on the right, we have the set of outputs. So then one thing with functions is that, let me see, every y corresponds to exactly 1x. If we were looking at the graph, every y corresponding to exactly 1x is basically the graph passing the vertical line test. If we're looking at the graph and we can draw a vertical line and it touches the graph more than once, it's not a function, right? So in the correspondence diagram, I call this like a merge, right? We have two different x values going to the same y. If you were to plot these ordered pairs, 1911 and 1011, they're going to be side by side, right? Two different x values going to the same y. So that's an example of something that would pass the vertical line test. No matter where you draw a vertical line through this function, it would only touch it once. So then is this a function? We would say yes. So again, in the correspondence diagram, I call this a merge. Merges are okay for a function, right? So I'm going to hit yes, this is a function. The domain. So the domain is going to be the set of input values, right? What are our set of inputs here? Our inputs are, let me see. Yeah, 19, 17, and 10. 19, 17, and 10. Okay, set of inputs. And then the range are going to be our set of outputs in this context, 11 and 4. Okay. So again, I am monitoring the chat. Feel free to either type in the chat or unmute yourself if I'm either moving too fast or if you have questions or anything of that nature. Okay. I'm going to go on to the next question. So determine the domain and range of the relation. State whether the given function is a relation. Okay, what's the domain? The domain is a set of inputs. So basically we type all those inputs. -2, -1, 0, 1, 2, 3. Okay. And then the range is going to be the set of outputs. We just type each output only once. -3, 4, 3. We did -3 already. We did 4 already, and 0. Okay. Is this a function? So another way, instead of saying every y corresponds to exactly 1x, or instead of saying it passes the vertical line test, in this context we can say if we have repeating x values, then it's not a function. Notice there are no repeating x values, so I'm going to say yes, it's a function. It's okay for the y's to repeat, but the x can't repeat. It's a lot like in life. If you're repeating your x's, then you can be you might be dysfunctional, maybe. Anyway, that's a really, really bad joke. It's a poor joke, but anyway. But yeah, in this context, we're not allowed for the x's to repeat. Determine whether the following equation defines y as a function of x. Okay, let me think about this one. The simplest way I can think to articulate this one is to look at the graph, right? So if we were going to graph this, we can basically choose some values of x, find the corresponding y, plot the points, connect them with, in this case, it would be a straight edge because the highest exponent on any variable is a 1. If we were going to graph this, like if we solve for y, we would get y equals -x plus 11. That's going to be, I could show you the graph, but y equals -x plus 11. It's going to be a diagonal line with a negative slope. It's going to basically pass the vertical line test. So is this going to be a function? I would say yes. Okay, that's about the best explanation I can give there. Just take a look at the graph. If you wanted to graph this on a graphing calculator, solve for y. All right, if you solve for y in terms of x, you can see it in your graphing calculator. That's, that's one way. Let's see. All right. So if we were to solve for y in this one, right? If say we wanted to look at the graph, we have this y squared equals this thing on the right. To get the y by itself, let me see. Let me let the student in. What's the time? Okay. To get y by itself, here we would take the square root on both sides. If we take the square root, whenever we take the even root, we have to introduce plus or minus, right? So if we could find two different x values that correspond to the same y, then that's an example of something that's going to fail the vertical line test, right? So for instance, say x were 2. If x were 2, that would be 4 minus 4 is 0. Let me think about it. I think I said something wrong now that I think about it. Every y corresponds to exactly 1x. So if we could find two different x values that correspond, if we could find two different y values that have the same x value, then I think that's how that works. Okay. Let me think about it. What could we let y be? When x is 0, okay, 2 plus or minus 2. Okay, so like for instance, instead of choosing the value of x, what if y were 2, right? If y is 2, let me write it out. I'm still trying to do it all in my head. Let me write it out so you can see it. Because I mean, I know what the result is here, but I'm just kind of stuck on how to articulate it. But let me write it out. Maybe that'll help. So let's do this. So this is question number 4. Ooh, it's doing that thing again. Give me a second. I always have to reboot this thing. It's like If I load it in advance, it just throws my stuff off. I should have had that page closed. Hopefully that's gonna behave properly. Okay, paper. And usually it just throws a lot of stuff off. Okay. So this is week 3, section 1.3 functions. Okay. This is question number 4, and it comes from 1.3, question 11 from the back of that section. I'm going to say, is it a function? Put question mark. And then we have this y squared equals 4 minus x squared, right? Okay, let's hop over to the tablet. Let me see if I can bring this one home. It's going to be here and like that. Okay. So is this a function, right? So we wanted to pass the vertical line test. So if we could find one x value that corresponds to 2 different y values, then it's not a function, right? Let me, hopefully this thing is behaving properly. I knew it was going to do that. All right. I have to hop back. So give me a moment. Let me see. Let's do the waiting room. I think it's this one. Okay. And after this. Okay. I think this may have been a suitor from the past. That name looks familiar. Oh, okay. Let me let him in. Let me hop back over here. Okay. And then let's turn this back down. Okay, it looks like this is a little bit loud. All right. Okay, sorry about that. So like for instance, let's see. Say okay, like if y was what 2. So say let y equal 2. All right, I just chose. I think that number will work. On the left, we're going to have 4. Let me think about it. So what I was originally about to do was this. If I solve for y, right? If I solve for y, we take the square root on both sides. We get y equals plus or minus the square root of 4 minus x squared, right? When we take the square root, we have to do plus or minus. So then if we could find 2 different x values that correspond to the same y value, let me see. I'm still saying that wrong. If we could find one x that corresponds to 2 different y's, yeah, that's it. If we find one x that corresponds to 2 different y's, that means it's going to fail the vertical line test. That means it's not a function, right? So let's see. What if it was 3, 4, 5? Okay. I'm going to let x be 1, right? So I'm going to say let x equal 1, right? So if x is 1, the corresponding y is going to be what? Plus or minus 4 minus 1. Then that's going to be plus or minus the square root of 3, right? So when x is 1, that corresponds to 2 different y values, right? If we were looking at this graph, this would fail. This is an example of something that would fail the vertical line test, right? So because we have one x that corresponds to 2 different y's, that's an example of something that's not a function. That plus or minus is the like main giveaway there. Let's see. Let's hop back here and transition. Okay. So long story short, this is a. Let's try it again. Unstable, it's okay. Final check. Let me see if I'm still online. That looks bad too. Okay, that looks better now. Oh, okay. So hopefully everything is still working. So I'm getting a lot of like error over here. Let me see. Give me just a moment. That still looks good. Let me turn this down. Okay, I'm gonna assume that it's still working. I'm hoping that you guys can still hear me, because I'm just getting a lot of things just like saying it's not working. Like I got the spinning wheel. Hopefully it's okay. All right, let's go on to the next one. Determine. Full screen. All right, okay, I'm not gonna worry about it. Okay, determine whether the following equation defines y as a function of x. Yeah. So, okay, again, with this one, I would just look at the graph. This is one you can actually graph. This is just going to be y equals the square root of x plus 3. So this graph, if you were to graph it like on your graphing calculator, it was going to be the top half of a sideways parabola, right? So if you only have the top half of a sideways parabola, will it pass or fail the vertical line test? It's going to pass, right? So we would say yes. I would just look at the graph, choose several values of x, find the corresponding y. You can put it in your graphing calculator, but that one is the top half of a sideways parabola. For instance, this one, if we were to solve for y, subtract x on both sides, when we go to take that square root, that's going to give us a plus or minus, and it's going to be the same argument as before. So is this a function, does this define y as a function of x? I would say no. Okay, because there's going to be a plus or minus in there, in this case. All right, this one, if we solve for y, we subtract the x cubed. Well, now we can take the ninth root. An odd root is okay, but if it's an even root, like square root or fourth root, that's when you're going to have that plus or minus. But the odd root, like if we did the ninth root on both sides, you don't have to do plus or minus. So is this going to be, is y a function of x? We're going to say yes. Okay, that's not intuitive. You would have to, you would just have to do some digging to get that one. Or have me tell you, hey, if you do an odd root, it's okay, it's a function. But if you do an even root, like square root or fourth root, it's going to be plus or minus, and it's not going to be a function. All right, so we have this. Find g of 0. Okay, so we have this function evaluated at several points. G of x is this thing here. So for instance, when x is 0, right? 9 minus 0 is 9. Square root of 9 is 3. 0 divided by 3. Is that okay, or is that the KO? That's okay. So that's going to be 0. All right? I don't know if you know my KO OK reference, but okay, when x is negative 3. Negative 3 times negative 3 is going to be what? Positive 9. 9 minus 9 is 0. Square root of 0 is 0. Is negative 3 divided by 0? Is that an OK, or is that a KO? That's an example of a KO, which means we cannot divide by 0, so does not exist. Okay. Hopefully this is okay. Let me check the chat. I'm assuming you guys, everything looks like it says that you can hear me, so I'm going to let it be. 5, when x is 5. What is that, 25? So is that 16? Negative 16? So 9 minus 25 is negative 16. Square root of negative 16 is not a real number. All right, so we're going to get not a real number there. Four thirds. What is that? 16 over 9. 81 minus 16. I'm probably gonna use my calculator. Let me open up my calculator. You're jumping around. You're doing that thing again. Okay, that still looks good. Let's get rid of this. Here's my calculator. Reload and refresh. Okay, I don't mind showing it. Let's hop over to the calculator. So we will go, actually, I'm gonna turn off the studio mode. That's like extra for no reason. Okay. This one, all right? I think I need to write down. Let me see. 4/3, all right? I just want to evaluate when x is 4/3. So what I'm going to do, I'm going to go to my y equals, and I'm going to type x divided by, what's the time? 5:21, okay. I'm going to say x divided by square root 9 minus x squared, okay? I'm going to quit, all right. And we want to know when x is 4/3. So I typed it into my y equals. I'm going to quit. I'm going to go to variables, y variables, 1 and 1. This is calling on the function I just typed. And we're going to evaluate the function when x is 4/3. I'm going to hit math as a fraction, see if it'll put it in a fraction. It won't. But we got a real number, okay? So let me hop back here to Pearson. Type an exact answer using radicals as needed. Okay, so we're going to have to write that one out for this one. Okay. So I'm going to write it out. Let me take some notes. This is question number 8. This comes from section 1.3, number 19. We're just doing g of 4/3, and then the one after this, oh, that's the last one? Okay. And then g of x is going to be, we got this 9 minus x squared under x, okay? Let's see, are we still there already? No. Let's hop back to the tablet. And let me get rid of the calculator for right now. Okay. So 4/3, right? We want an exact answer, so then we want to evaluate g of 4/3. So that's going to be 9 minus 4/3 squared. Get the square root of all of that under 4/3. Let's clean up that 4 there. Okay. So then this is going to be the same as over 1. So 81 over 9 minus 16 over 9. We want the square root of that result, all under 4/3. Okay. 81 minus 10 would be, let me say 81 minus 20 would be 61 plus 4 is 65, right? So this looks like it's going to be 65 over 9. We got the square root of that under 4/3, okay? This is going to be the same as, so when we say one fraction divided by another, we can do keep, change, flip. So this is the same as 4/3 times 3 over the square root of 65, okay? So I think we're home free now. The 3's cancel. 65, there's a 1, 15, 13, so 5 times 13, so no perfect squares there. We can either leave it as 4 over the square root of 65, or it might be 4 times the square root of 65 over 65. It should be one of those two, as long as we didn't make any mistakes. It's actually kind of nice here. So it's like storming here. It's like lightning and thunder. But it's soft. So it's like one of those really nice, rainy moods where you just want to like, be asleep. Let's hop back over here to Pearson. Okay. So if we want an exact answer, first I'm gonna try the one where we did not rationalize. I'm gonna try that one first. So I'm gonna do my 4 divided by the square root of 65. I'm gonna go with that one. Okay. All right. There should have been some questions there, but I'm not gonna press it. So I'm gonna go on to the next question. Okay. Find the domain. All right. So I want to say generally for our purposes in this course, we have like, what's the time? We have like, I want to say there are 3 main scenarios as far as finding the domain. This one is called a rational function. So with the rational function, in general, the domain is all reals except any x that makes the denominator 0. I mean, that's the main thing there, right? So here we can say, oh, the domain is going to be all reals except, in this case, any x that makes the denominator 0. So if we set the denominator equal to 0 and solve, I think we get -4. So when x is -4, it gives us a 0 in the denominator. So every real number should work except -4. And that looks like A. So this is a discussion on grouping symbols, all right? If we look at A, okay, so I think most people get what infinity is. That means it just goes on forever. This goes off to the left forever. This goes off to the right forever. Parentheses means we get close to that thing, but we do not include it, right? So this says we go to the far left and then up to this -4, all right? Every number that gets really, really close to -4, but the parentheses mean we do not include -4. Right here, parentheses mean do not include -4. We get really, really close to -4 coming from the right, but we do not include -4. Versus B uses square brackets. So the difference between parentheses and square brackets, parentheses we get really, really close, but we do not include that endpoint. With square brackets, we get really, really close, and we do include that endpoint, right? So this means we include all the numbers to the left of -4, and we include -4. This means we include all the numbers to the right of -4, and we do include -4. But remember, from the beginning, we wanted to throw out -4, right? So the only solution that captures all the numbers except -4 is A, right? This is only half the solution. Like there's a whole nother set off to the right, and this is only one half. There's another set off to the left. So the only one that captures all of them is going to be A. Okay, hopefully that wasn't too wordy. And it just like got cold all of a sudden. It's like dark and rainy and cold. I'm like, man. It seems like it's almost like out of nowhere. Find the domain of the function, right? So again, for rational functions, in general, the domain is all reals except any x that makes the denominator 0. So in this case, we need to set the denominator equal to solve. So if we say x squared minus 25 equal to 0, we're going to get x squared equals 25. We take the square root on both sides. X equals plus or minus 5, right? So long story short, the domain of this is going to be everything except plus or minus 5. So to capture everything except plus or minus 5, the far left is going to be -infinity up until -5. I'm going to hit cup. Cup means like or union. And then we're going to go from -5 to 5. Hopefully, it's not too much. And then we're going to combine or cup. And then we got this 5 to infinity. Okay? And again, feel free to like stop me or use the chat if you have questions or if anything is not clear. If you don't speak up, I can't speak for you. Like you have to open your mouth if you want clarity. Otherwise, I don't know what to tell you. But you just have to ask. That's all you have to do, is just speak up. Find the domain. So now we have an added restriction here. This is still a rational function. So we still don't want to divide by 0, but now we have the square root function. So we have an added restriction. Not only can we not divide by 0, but we can't take the square root of. So this is actually the second function. The first one was a rational function. With rational functions, we cannot divide by 0. The next one is this square root function, right? When we have an even root or we have square root, we cannot take the square root or we cannot take the even root of a negative number, right? So in general, this is called the radicand, the thing inside the square root. In general, the radicand has to be greater than or equal to 0. But because it's in the denominator, it cannot be equal to 0. So this radicand has to be strictly greater than 0. Okay, so we had to put those two restrictions together. I don't know who it is, so they're going to have to go to voicemail. So x minus 8 has to be strictly greater than 0. In other words, if we add 8 to both sides, x has to be strictly greater than 8. So we're talking about all the numbers to the right of 8. So we're going to say parentheses. We're talking about from 8 to infinity. All right. Now, if we get this solution set, we can check it before we submit it. So for instance, we're saying numbers like 9, 10, 8.5, anything to the right of 8 should make the original true. Let's see when x is 9, all right? If x is 9, 9 minus 8 is 1, square root of 1 is 1, 9 times 6 is 54, so we got a good result. If we let x be 7, it shouldn't work, right? So 7 minus 8 is negative 1. For this discussion, we can't take the square root of negatives, so that's why it's not working. If we let x be 8, 8 minus 8 is 0. We don't want to divide by 0, so you know, you can choose a few points to make sure that make sure this makes sense. It should make sense. If it don't make sense, then keep looking at it, keep working with it. Again, the rule of thumb here with rational functions, for our purposes, the domain in general is all reals except any x that makes the denominator 0. So we need to set the denominator to 0 and solve. Well, because it's multiple choice, now I was going to factor, but I'm like, well, we got a multiple choice. So it looks like 2 and 1. Let's just write it out. Let me write out what I know I need to write out. Even though we could just kind of like use the results, but I'm going to write it out. So this is question 12. This comes from section 1.3, question 21. We have this f of x equals, we got x squared minus x minus 2 under x plus 2, right? I'm going to say the domain, question mark, okay? Let's hop over to the tablet, which is here. Okay, that looks good. So the domain. So again, in general, for something like this, the domain is all reals except any x that makes the denominator 0. So what we need to do is set the denominator, this guy, we need to set it equal to 0 and solve whatever answer we get. That's what we need to throw out, okay? So I'm gonna just kind of, well, this is fine. So we're looking for we wanna factor this into can we factor it into something like this, where we have x and x. Can we find two numbers that multiply to give us -2 and add to give us -1? Right? I think it's going to be -2 and 1, right? -2 and a +1. Notice that -2 times 1 is -2, and -2 plus 1 is -1, right? So now we have two or more things that multiply to give us 0. At this stage, we use a technique called the zero factor property. So when two or more things multiply to give us 0, either the first thing is equal to 0, and we solve, or the second thing is 0. So as long as either one of those is 0, it's going to make the whole thing collapse to 0. So what we do here, we set each thing to 0 and we solve. So if we said x minus 2 equals 0, then x equals 2. If we say x plus 1 equals 0, then x equals -1, right? So long story short, we're saying the domain for the original function is going to be all reals except 2 and -1, right? So if we're looking at the number line, here's 2, here's -1. We want all the numbers except this guy and this guy, right? So if we're going to do everything except, that means we're talking about all the numbers to the left of -1, all the numbers between -1 and 2. Let me just make that better. So all the numbers between -1 and 2, and all the numbers to the right of 2. But we use parentheses because we don't want to include the -1. We use parentheses because we don't want to include the -2. That's the graph of the solution, right? So now that we have the graph, we can look at this in interval notation. Now, how far left does this graph go? The far left is -infinity. Up until -1. Infinity always gets parentheses. Right? We never reach infinity in human form. Don't get me started on all that. But in human form, we never reach infinity, right? And in this case, because we wanted to throw out the -1, does the -1 get parentheses or does -1 get square bracket? We literally just did this. It should get parentheses. Union. Then we want all the numbers from -1 to 2. Again, these get parentheses because we don't want to use these numbers because they're going to make zeros in the denominator. Union 2 to infinity. That's where that comes from. Okay. Hopefully that made sense. Okay. Let's do like this, like this. So this is kind of a tangent. For some reason, it's just entered my mind. I don't know why I'm excited about it, but I am. I think they're finally gonna become. I think they're gonna be coming out with the Matrix 4 soon. Like I think I saw a preview or a promo or something on HBO Max. I was like, they're doing Matrix 4 finally. I was like, oh man, that's no small feat to like live up to the Matrix. I mean, nothing to me. Nothing holds its weight to that first one. The second and third, they were fun, but it has so much potential, and I'm curious to see what they do with it. Anyway, that's just some shameless marketing and plugs for like other people making other people money until we can figure out how to do this for ourselves or just transcend money altogether. But okay, only one that matches it looks like is D. That's exactly what we got. So we're gonna go with D. Yay! On to the next question. Use the vertical line test to determine whether the graph is a function. Okay. Can we draw a vertical line and it touches it more than once? Yes, we can. Right over here. Right off the rip, right? Notice if we draw a vertical line here, it touches the dots more than once, so that means it's not a function. So is this a function? No. That's an example of something that fails the vertical line test. Notice here we have a diagonal line. No matter where we draw a vertical line, it only touches the graph once. So is this a function? Yes, it's a function. Because that's an example of something that passes the vertical line test. Hopefully this is okay. So this one should be quick, right? Is this a function? Does it pass or fail the vertical line test? Can you draw a vertical line and it touches it more than once? Yeah. So if you can draw a vertical line and it touches it more than once, then it's not a function. So once you have the graph and you get a good sense of the important components, it's not too bad. You just need a good graph, which you can do. Like we're using computers. If you don't have a graphing calculator and you want to see these graphs, some free graphing software is GeoGebra. GeoGebra is good, and I think another one that students use is called Desmos. Um, those are two free graphing softwares where if you just wanted to see a graph, you can use it. You just got to play around with it, and eventually you get it. I know this is different because everything is asynchronous and we're kind of doing things on our own. Hopefully, you guys are watching my lectures because if you're watching this and you're not attending my class, I'm going to come looking for you because it's going to mess up your money. Make sure to get your attendance credit. Like just pop into class. You don't have to stay. Just get your credit, so it don't look like you're MIA. And I intentionally put that clause of the credit thing because what I noticed in the past is that students were just gone and then all of a sudden, they just appear out of nowhere. Like once down the line, I was like, yo, where you been? So I need you guys to check in during class time, but you don't have to stay. Okay, that's important. Just so I know that you're breathing. You got to check in. Okay. Answer the questions about the following function. Okay. Is the point -1, 2 on the graph, right? So we want to know, what's the time? Because I'm just going, okay, we got 10 minutes. This is a long question. I feel inclined to save this for next time because I need to get set up for my next class. And I think I will save this one for next time. I'm not going to do this one right now because it's a little bit long. We do have a little bit of time, but I want to save some things. Let me check the chat. I don't think there are any questions in the chat. Let me hop back over here. Let me do something real quick. Paper. Okay. And let's do like this. Okay. So where is it? Okay. So let me see if I can't think of anything else that's pertinent. I'm just intentionally trying to leave this for next time so we're not like we have something for next time. The main thing is just kind of keep making your way through the assignments that are in Blackboard. Again, we are using Pearson, but I linked it to Blackboard. Also, make sure that you're getting your attendance credit on a day-to-day, right? So just like if class starts at 5, you want to be online about 4:50. I usually take attendance leading up until 5 o'clock. And then once I do that first wave at 5, then what I'll do, like, okay, if people show up between 5 to 5:15, I usually mark them as late. After 5:15, I'll let you in the class, but I'll probably stop taking attendance at that point. You're going to be absent after 5:15. And then I think we have like if you get like four, once you hit that fourth absence, then you could be like kicked out of the class. And that can really mess up your money. And like honestly, I'm probably going to be one of your more chill teachers. I know this subject matter is kind of challenging. That's why I try to be chill. I know I can be a little bit high strung, but I try to be chill because the nature of mathematics is kind of intense all by itself, and a lot of people have anxiety with it. So I try to relieve some of that pressure because I know what it feels like. I was there. So speak of the angel. Let me see if I can find a student. I'll be kind of lax right now. I had somebody that just logged in. Was he here before? He may have been here already. Let me see. Did he get attendance? Oh, he's for the next class. Okay. I'm gonna let him be then. Um, what is it? But yeah, I try to be lax because the nature. I know a lot of people have anxiety, especially in college algebra. I know that people have anxiety with this, so I try to give you as much time as I can. Like that's why I do unlimited attempts on the homework assignments. I actually have a lot of soft deadlines, but you still got to meet me halfway. You know what I mean? There's only so much I can do on my end. So on that note, if there aren't any burning questions, I'm going to actually end the session here. I think we're okay. Um, I'm going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace. Chilling. Oh, I guess it was the end of the song. I knew I was about to start freestyling. All right, I'm not feeling this song. We're gonna cut it out. All right, guys, take care.